Hello, everyone. Good morning, good afternoon, good evening, wherever you're joining us from around the world. You're watching Spaceflight Now's live coverage of the latest mission from NASA's Kennedy Space Center. I'm Will Robinson Smith, reporter with Spaceflight Now. Good to be with you, joining you virtually from nearby the Johnson Space Center here in Houston, Texas. This is one of those when it rains, it pours kind of weeks for space flight coverage, as there's a lot going on around the country. Of course, we started this week with the launch of a mission for the National Reconnaissance Office, flying from Vandenberg Space Force Base. So, certainly appreciate our Spaceflight Now editor, Stephen Young, doing the yeoman's work of making sure that launch was covered, since simultaneously here in Houston, NASA was introducing its latest astronaut candidate class, the 10 newest Americans who will be going through a couple-year training period to prepare for certification for future space flights. Of course, we've also been getting some briefings here, both yesterday and coming up later today, on the upcoming launch of NASA's Artemis 2 mission, flying from the pad adjacent to the one you're looking at right now, Launch Complex 39B. One of the big notes to bring to your attention regarding that, if you weren't following along on our social media thread, is that the newest target date is no earlier than February 5th for the launch of Artemis 2. We'll, of course, have much more coverage on that coming out of this reporting trip. So if you're not already subscribed to the channel, now's a good time to do so. And follow us, of course, on our social channels. You can find us most places simply at Spaceflight Now. Coming to today, though, of course, we're tracking down less than an hour to go ahead of the flight of the rocket you see there in the dead center of your screen. SpaceX's workhorse, the Falcon 9 rocket, set to depart in about 57 and a half minutes, delivering not one, not two, but three spacecraft that will be heading out on a million-mile journey to a gravitationally stable point between the Earth and the Sun, a million miles from the Earth, called Lagrange point 1. This is a big heliophysics day for NASA, sending these three spacecraft on their way. One of those, though, is going to be operated by NOAA, the National Oceanic and Atmospheric Administration here in the United States. We'll, of course, be talking more about these three distinct spacecraft, three distinct missions throughout the course of this broadcast with the remaining time that we have. Before we get any further, though, do want to thank the about 250 of you who are watching along with us live at this point in the morning. I know it's quite early for folks in Florida and beyond in the United States, so certainly appreciate you getting up early with us. If you haven't already, you could do us a big favor just by clicking that like button and sharing the stream, allowing some more folks to find their way into this live launch coverage. Want to thank as well our moderator du jour, at least for now, is Rick Donner. You can help Rick and any of the other mods that join in throughout the course of the broadcast by following our rules of the live chat. We ask that you refrain from delving into overt politics or religion, that you converse in English so that our moderators can respond as appropriate. Emojis are perfectly fine. We just ask that you don't create multiple lines of them so it takes up a huge section of the live chat. Also, if you could hold off from using all caps, that'd be greatly appreciated. Last but not least, if you treat each other with the kindness and respect that you yourself would like to be treated, then we'll all get along swimmingly. You can see the sun is just starting to rise here on Florida's Space Coast, a little bit of color in the sky. We've got our full team out and about getting ready to track this Falcon 9 rocket from all angles, including some special shots that we're hoping will pan out. We'll be bringing those in post liftoff. Photographer John Pisani is running the technical operations of the broadcast alongside our editor, Stephen Young. Adam Bernstein out and about, getting all of the cameras here at the press site right and ready in anticipation of this launch here in about 54 and a half minutes. Our Michael Kane is also off site, setting up one of those aforementioned special shots. So all of them in position to get some really cool images of this launch today. So now's a great time to head on over to X and be sure if you're on that social media that you're following the fellas. You can find John at John Pisani Photo, Michael Kane at MD Kane Jr., and Adam Bernstein at ABern NYC. And again, of course, if you're not already following us at Spaceflight Now, you can find us simply at the handle Spaceflight Now. We are on Threads, Blue Sky, and Facebook, in addition to X. We'll also be joined a little bit later in the broadcast by our friend Pete Carsons with Max Q Productions, as well as Chuck and Jen Briggs, who are checking in now. We'll talk more about the trajectory a little bit later on in the broadcast once we get closer to the T0 point in the countdown. But just as a nod to where the rocket's going to be flying, it's going to head out due east once it leaves the pad. So for those of you who are in Central Florida and in the vicinity, either in North or South Florida, hopefully the weather is clear in your neck of the woods and you've got a good eye on the rocket as it heads out over the waters of the Atlantic Ocean. Sunrise this morning is set for about 7:12 a.m. Eastern, so just about 18 minutes ahead of the liftoff of this Falcon 9 rocket as it prepares to fly out to start the journey delivering those 3 spacecraft to their destination eventually. You can see at the top of the Falcon 9 stack on the payload fairings the logos, the mission patches for each of the payloads on board. Before we get more in the weeds on that, want to thank our wonderful channel member community for continuously standing by us and supporting us with these live launch opportunities. Y'all make this happen, and we certainly do not take that for granted. So thanks to folks like Cumulus Granatus, Jake, Donald Evans, Mark Pachotnik, Sue Straub, Silver for Lunch, and many others. Amy Ketchum, good morning to you. Channel membership comes with a number of perks, including discounts at our online shop, which is shop.spacelightnow.com. Access to member-only videos here on YouTube, access to our members-only Discord server, and of course the ability to watch all of our live launch liftoff moments from here in Florida in 4K. Of course, with 3 marquee missions on board this Falcon 9 rocket, hope you had an opportunity to check out our explainer videos if you want a really good multi-minute illustration of each and every payload that's on board this Falcon 9 rocket. You can find those on our YouTube channel. It'll take a few months for these spacecraft to find their way out to Lagrange point 1. They should be arriving in the January timeframe, and they'll each go through a commissioning period of a few months before they get all of their various instruments calibrated and they can start their distinct science missions. So even if you hadn't had a chance to check out those videos, they're a good primer on the mission and are not overly tied to the launch as far as timestamps on those. So they'll be fresh and ready for your viewing whenever you have an opportunity to go ahead and check those out. That's a little bit of housekeeping here as we're getting going. 6:41 a.m. Eastern. If you have a comment or question about this mission or just want to offer a little bit of support with our coverage today, you can use the YouTube Super Chat feature to have your comment or query elevated for discussion. Of course, assuming that your comment is appropriate for the broadcast. Not only will you be giving us some interesting things to talk about as we cruise on through the count, but you'll also be supporting what we do here at Spaceflight Now. And that, my friends, is very much greatly appreciated. As the sun continues to rise here on the East Coast, we inch closer to official sunrise. You can see it's a very clean-looking Falcon 9 rocket booster there. Reason being, this is B-1096 in the SpaceX fleet. It's going to be making its second trip to space and back after previously supporting SpaceX's first launch with Amazon's Project Kuiper satellite internet satellites on board. That was back in July. Speaking of Kuiper, tomorrow we're looking towards the launch of the next batch of Kuiper satellites heading into low Earth orbit. Not on a Falcon 9, but over at Space Launch Complex 41 on a United Launch Alliance Atlas V rocket. Of course, have live coverage of that mission distinct to that, beginning about an hour prior to liftoff. So we hope to see you back here for our coverage of that Atlas launch, which will use 5 solids flying in its most powerful launch configuration. But ULA nicknames the Bruiser. We'll obviously have more to say on Kuiper and where things stand with that mission coming up tomorrow. For now, as you can see in the clock in the upper right-hand corner of your screen, we're T-minus 47 minutes, 42 seconds in counting from the planned liftoff of this Falcon 9 rocket. We have noticed a little bit of venting here from the strong back. That's fairly typical here at pad 39A. We're, of course, not into the tanking process just yet. In a little less than 10 minutes, that's the nominal point at which the SpaceX launch director will make the call on the start of prop load. You may also, from time to time, hear what you just might have heard over the loudspeaker coming from the vehicle assembly building adjacent to the press site here. Of course, as NASA continues towards the planned launch of Artemis 2 no earlier than February 5th, things are moving along quite steadily in preparation for that. NASA's just about a week away from taking the Orion spacecraft, now with the launch escape system, which that work is set to finish out towards the end of this week, and next week it'll be transferred over to the vehicle assembly building ahead of stacking and integration with the rest of the SLS rocket. And we'll have the full stack of the Artemis 2 launch vehicle and spacecraft. All that being said, you may hear some announcements over the loudspeaker as we go throughout the broadcast. We have no control over that. It just happens periodically. So if you hear a little bit of a mumbled additional voice beyond my own, that's clearly not a call out related to this mission. That's probably what you're hearing. As we're just about 45 minutes away from the planned liftoff of this Falcon 9 rocket, let's go ahead and step through that countdown timeline that I was just alluding to, let you know the milestones that are still ahead for a good liftoff of the Falcon 9 rocket you see there live on the right-hand side of your screen. As mentioned, roughly T-minus 38 minutes out is when the SpaceX launch director will make the call that they're go for the start of prop load. If SpaceX feels like they're in a good posture, they can make that call early. They do their readiness poll electronically. Once the go-ahead for tanking is granted, then fueling of the Falcon 9 rocket will begin at T-minus 35 minutes with a loading of RP-1, a rocket-grade kerosene on board the Falcon 9's first and second stages. And at the same time, liquid oxygen will begin flowing on board the rocket's first stage. T-minus 30 minutes is when SpaceX starts to load cryogenic helium onto the pressure vessels for the Falcon 9's first stage. Same will be true regarding the second stage a couple minutes after that point. That helium is important because it's used to pressurize the main propellant tanks during flight. T-minus 23 minutes is when second stage RP-1 tanking is complete. And about T-minus 20 minutes and 50 seconds is when the strong back chill-down process gets underway. This is when SpaceX is thermally conditioning the feed lines there at the pad prior to
Just wanted to add him as honorary member of this poll, starting with CFA.
Thank you, NOM. CFA is go.
NASA CE.
NASA CE is go.
SMA.
SMA is go.
SMD.
This is SMD. IMAP is go.
NASA MIM.
NASA MIM is go.
LSP.
LSP is go.
NASA team is ready for propellant load and launch.
And what you were just hearing there was a readiness poll from, as you just heard, NASA LSP, the Launch Services Program, which is managed here at the Kennedy Space Center. So that's a separate part of the launch team, in addition to SpaceX's team, and their launch readiness poll, as I mentioned, is done electronically. But given that this is a NASA mission on board with two NASA spacecraft, and NASA is also responsible for procuring the launch for NOAA's spacecraft, the SWIFO L1, or Space Weather Follow-on Lagrange 1 payload. That's why we may hear some periodic calls about the readiness and the status throughout the course of the countdown as it concerns those three spacecraft, since NASA LSP is also very much in the loop on this mission. You can actually see a couple of those mission patches that I was alluding to before. The logo for NOAA is in the bottom left-hand corner from our vantage point on the fairings, and just above that, the blue oval with, it's a little bit hard to see, but that's a sun icon with the SWIFO L1 spacecraft in the foreground. That is the NOAA mission patch for their specific payload above the agency logo beneath that. You can just barely make out a little bit of the IMAP, the P in IMAP that is sort of peeking around the edge of the fairing from this particular vantage point. These are some clean-looking fairing halves that are quite probably flying for the first time on this mission. Well, SpaceX is working towards the certification of its fairing halves and Falcon boosters for up to 40 flights apiece. Different missions have different requirements, and of course, in order to keep expanding SpaceX's ability to launch, that means bringing new fairing halves and new boosters into the fold periodically. It may also have to do in part with the sensitivity of the payload on board. Last month, John Pisani and I had the opportunity on behalf of Spaceflight Now to head into the clean room for these spacecraft as they were being prepared after their fueling campaign had concluded. And we can tell you with very much certainty that it is a very sensitive environment as far as these three spacecraft are concerned.
This is the launch director on the countdown net. The propellant load and launch go, no-go poll is complete, and we are go for propellant loading and launch.
And a good confirmation from the SpaceX launch director following the words that we heard from NASA LSP. SpaceX also ready to start the prop load process, which again, as we were just discussing, will start at the T-minus 35-minute mark in the count. So given the readiness of NASA and the readiness of SpaceX, things are moving along quite well this morning as we've got now 39 minutes remaining on the clock. Continuing on our conversation about the countdown, once the chill down process has begun, we'll see that visually manifest as the so-called big vent that'll happen here at pad 39A at about T-minus 20 minutes and 30 seconds. That venting will last roughly 4 minutes in duration, tapering off and setting the stage for second stage LOX load to begin at the 16-minute mark. Moving right along. T-minus 7 minutes is when the chill down of the 9 Merlin engines at the base of the Falcon first stage booster gets underway. SpaceX will flow a small amount of liquid oxygen through the plumbing and turbo pumps, helping to protect those engines from the risk of thermal shock and damage during startup. About 6 minutes ahead of liftoff, the first stage kerosene tank should be full. Then at T-minus 4.5 minutes, we'll see the retraction of the strongback. First, the clamp arms just beneath the payload fairings will open up, and then the transporter erector, otherwise referred to as the strongback, will recline a few degrees away from the Falcon 9 rocket, and it will stay in that position until liftoff. Then at that point, it'll pull back in a much more rapid fashion to clear the way for the vertical climb of the Falcon 9 rocket. 3 minutes before takeoff, the first stage liquid oxygen tank should be full. 2 minutes out, same will be true on the second stage. At that point, the Falcon 9 will be fully loaded with 1 million pounds of propellant. In the final 60 seconds, as we hear the call that the Falcon 9 is in startup, what that means is that the control of the countdown will be handed over from the ground sequencer to the Falcon 9's onboard flight computers. Simultaneously, the propellant tanks are brought up to flight pressure. SpaceX launch director.
This is the launch director with abort instructions. For non-urgent no-go conditions, brief the CE or LD and they will approve aborting the countdown. For urgent issues affecting the safety of the operation, operator shall call hold on the countdown net. Launch control will abort the launch auto sequence immediately and proceed into the launch abort auto sequence. At T-minus 10 seconds, launch control will be hands-off and relying on automated abort criteria for the remainder of the count.
Good words from Mission Control. The standard overview, just letting everyone know what the procedure would be for an abort scenario. That being said, things are progressing quite well as we've been hearing throughout the course of the countdown up to this point. We're just about a minute away from the start of tanking. So we'll go ahead and finish up our countdown timeline. Once the SpaceX launch director gives their go-ahead for liftoff, then the final pre-launch item will be the engine ignition command being issued at T-minus 3 seconds. And if everything has continued to progress well up to this point, then at T0, we'll see the liftoff of this Falcon 9 rocket with these key NASA and NOAA payloads on board. SpaceX, NASA, NOAA targeting a liftoff of this mission at 7:30 a.m. Eastern, 11:30 UTC for those around the world.
The launch auto sequence has started.
And as you just heard, tanking of the Falcon 9 rocket is now underway. For those of you who were not with us when we first discussed the tanking of this launch vehicle, starts with the loading of RP-1, which is a rocket-grade kerosene, on board the Falcon 9's first and second stages. Simultaneously, liquid oxygen is now flowing on board the rocket's booster, tail number B1096.
So in the event of a government shutdown, of course, we will cease the work. The government is shut down.
Time now, T-minus 32 minutes, 44 seconds and counting. Heard a little audio prelude of what we were just about to pivot to in the run-up to the liftoff of this mission. Of course, time continues to march on, and there's plenty else happening in the country. And that includes what we've gotten, unfortunately, used to here in the United States, which is a budget battle, which periodically does result in a government shutdown, which would constrain the ability of the federal government to do certain operations and limit what can run, what cannot run. And so, given that this will come potentially at the end of this month, pivoting into the start of October, and these spacecraft will be very newly heading on their way to Lagrange Point 1, in addition to all the other NASA missions currently underway, including the run-up to the Artemis 2 mission. We spoke with the Associate Administrator, Nikki Fox, with the Science Mission Directorate yesterday to learn more about what will happen to NASA science in the event of a government shutdown, should that happen. Here's NASA's Nikki Fox.
Cease the work. The government is shut down, and so we will focus on making sure that we maintain life and we maintain property. So of course, any astronauts on the ISS, we're taking care of them. Our missions in space that are operating, we're very much taking care of them. For IMAP and the missions launching, which we're all excited to talk about, then we will be putting a lot of effort on maintaining those. Any other work that does not pertain to life or property, then we will stand down until the government tells us to come back, whether it's under a continuing resolution or whether it's under an appropriation. At that point, we'll know the level that we'll be operating. So that we'll either be given guidance in the event of CR, or we'll be given an appropriation. So we look forward to getting that guidance and then continuing to do the great science that we do at NASA Science.
Again, do you want to just preface or remind folks that a government shutdown is not a certainty, but given that it is a high probability, T-minus 30 minutes, want to mark that. We, of course, wanted to know for our own benefit, but also to, of course, share with you all what would happen with key NASA science missions as best we're able to get an answer to that at this point in time Obviously, things are still in flux, and we'll continue monitoring the situation and let you know if there is a government shutdown, the missions that are impacted, that are in flow at this juncture. Less than 30 minutes to go before liftoff of this Falcon 9 rocket. You can see some of that vapor trailing off from the base of the booster. Good visual indicator that, as we were, of course, made aware of through those callouts, that tanking is underway. Right now, SpaceX is also loading cryogenic helium onto the pressure vessels for the Falcon 9's first stage. It will do the same on the second stage coming up here in the next few minutes. While we're cycling through some of these beautiful images around Florida's Space Coast, circling around the pad from various perspectives, want to briefly touch on the weather, and thankfully it will be just very briefly because launch conditions are very good today. The 45th Weather Squadron forecast yesterday a 90% chance for favorable weather at liftoff. This morning, that has been upgraded now to a 95% chance for good launch conditions. So things trending very nicely ahead of the liftoff of this Falcon 9 rocket with 3 key spacecraft on board. Right now, you're taking a live look inside the mission control room for one of the three spacecraft that is flying today, the Carruthers Geocorona Observatory, named after Dr. George Carruthers, a three-time alum of the University of Illinois. His telescope was flown to the moon during the Apollo 16 mission, and it was able to capture images of Earth's geocorona for the very first time. That work has inspired this mission, which will, from its vantage point at Lagrange point 1, be able to image far more than Dr. Carruthers was able to accomplish in his time back in the early 70s, given that from the moon, they actually weren't able to get a good vantage point of the entire geocorona in one go. So being a million miles away from the Earth and then looking back at it, the Carruthers Observatory will use its wide field imager in order to take pictures of the geocorona continuously over the course of its minimum 2-year life span. However, it does have fuel on board to operate potentially for more than a decade beyond its planned operating lifetime. So NASA and its partners on this mission are planning to get some good science data for the foreseeable future with the Geocorona, or the Carruthers Geocorona Observatory. Just one of the three payloads that's flying today, heading up to L1. Currently T-minus 22 minutes, 44 seconds and counting. In the next couple of minutes, we'll see the start of the so-called big vent as SpaceX thermally conditions the feed lines there at the pad prior to second stage LOX load. Time now T-minus 20 minutes, 50 seconds and counting. That thermal conditioning process I just mentioned is now underway. We should see the big vent beginning in now roughly 10 seconds.
Stage 2 RP1 load is complete.
Good call on upper stage RP1 loading, and you're now seeing the big vent underway. This vent will last about 4 minutes in duration, setting the stage for liquid oxygen to start flowing on board the rocket's upper stage, beginning at T-minus 16 minutes. Time now, T-minus 18 minutes, 5 seconds and counting. With a couple more minutes remaining on this big event, want to thank the more than 2,000 of you who are watching along with us live today. If you haven't already, you could do us a big favor just by clicking that like button and sharing the stream, allowing some more folks to find their way into this live launch coverage. Given the hour and the few clouds in the sky from these multiple camera angles, it's a beautiful morning for the countdown to a hopeful liftoff of the Falcon 9 rocket. That's coming up here in just a little more than 17 minutes. The big vent has just about 35 seconds remaining before that tapers off, and second stage LOX load begins at the 16-minute mark. All is moving very smoothly with this countdown today towards the liftoff of these 2 NASA and 1 NOAA spacecraft. Taking a look at our live chat here, I want to thank Tinable for a $3 super chat. Really appreciate that. Thank you for your support this morning.
Stage 2 LOX load has started.
And a good call from SpaceX regarding second stage LOX load. And as you can see, the big vent has now wrapped up, clearing the way now that the lines are thermally conditioned for LOX to start flowing on the upper stage of the Falcon 9. As we're gearing up for this launch in now less than 16 minutes, want to bring in some of the iconography to talk about. This is the mission patch as designed by SpaceX, noting the principal players in the IMAP part of the mission. Of course, SpaceX as the launch provider with its Falcon 9 rocket. NASA is the main agency overseeing the IMAP spacecraft. Also, some of the other 2 major partners are the Johns Hopkins University Applied Physics Lab and BAE, who are behind the instruments and the construction development of the spacecraft itself. You can see IMAP there is the little icon at the bottom of the screen next to the name IMAP. The other 2 little green spacecraft, those are the SWIFO L1, which is the one with the boom extended from it on the right. And then to the left of that is the Carruthers Geocorona Observatory. Giving you a look at not just the sort of cartoon version of them, but the spacecraft as we were able to see them in the clean room. This next series of photos come to us from our photographer, John Pisani, who was thankfully able to join and going into his first opportunity inside a clean room, getting to see these spacecraft up close. We were also wearing those protective garments that you're seeing these technicians wearing in this photo. This is a picture of the IMAP spacecraft itself. IMAP stands for Interstellar Mapping and Acceleration Probe. It's going to be doing a comprehensive mapping of the heliosphere and learning more about the dynamics between the solar winds that provide the pressure within the heliosphere extending from the sun, pushing against the cosmic radiation that comes from beyond the outer boundary known as the heliopause. And so seeing the interplay between those, the particles that are emanated from the sun and the energetic neutral ions that come back from the heliopause that'll be heading into some of the instrumentation from the IMAP spacecraft. And that'll give us a much better understanding of both the size and the dexterity of the heliosphere itself. Actually, let's go ahead. We're seeing some images now inside the Johns Hopkins Mission Control Center. Calling an audible, if we can bring that in. You can see now inside where this team will be operating the spacecraft. According to NASA, they should be getting control or a signal back from the vehicle at about L plus 1 hour and 33 minutes post liftoff. That's a rough estimation of when they should be getting signal from this particular vehicle. IMAP will be the first of the 3 spacecraft to be jettisoned from the Falcon 9's second stage once the rocket takes flight. IMAP deployment is coming up at about T plus 1 hour, 23 minutes and 51 seconds. It'll be followed roughly 7 minutes later by the deployment of the Space Weather Follow-on Lagrange 1 or SWIFO L1 spacecraft. That's from NOAA. Let's go ahead and show you the next vehicle. This is the Carruthers Geocorona Observatory. This will be the last spacecraft that will be deployed at T plus 1 hour, 36 minutes and 46 seconds post liftoff. Here's an image of the SWIFO L1. It has a suite of 6 instruments, and as compared to Carruthers and the IMAP instrument, which will be gathering more research data in order to better inform how we know and understand and can respond to various elements of space weather. SWIFO L1 from NOAA is the action point spacecraft. So its suite of instruments are designed to monitor the sun's activities and be able to send that information back to decision makers here on the ground in order to better protect property and infrastructure from the impacts of solar weather, in particular coronal mass ejection that could have negative consequences for things in orbit like satellites and astronaut health, as well as things that affect us directly here on the planet who are not in space and are not satellites, but obviously, you know, we are all very much connected to our space ecosystem through the GPS constellation and other key satellites that affect our day-to-day lives. But strong solar storm can also negatively impact the power grids depending on its severity, its duration. Airlines also rely on communications that could be impacted by a strong solar storm. So the tools
are on internal power.
That are now on internal power, as you just heard, will be brought to bear in protecting the Earth from impacts of solar storms. NOAA is also sending a coronagraph on board a future mission from the European Space Agency that is set to head out to Lagrange point 5 as opposed to the spacecraft at L1. And the benefit of that is at the L5 point, that spacecraft will be able to see things like sunspots on the sun as it's rotating towards the Earth. So we'll get a little bit of a heads up on some of those events before they start potentially having a direct impact on us here on our little blue marble. Just under 9 minutes to go. Here's one last image I want to share with you all of those 3 spacecraft before they were encapsulated fully inside the payload fairings and rolled out to the pad, where you now see them stacked, of course, at the top of the Falcon 9 rocket, getting ready to lift off here in just about 8.5 minutes. You can see some of the photographers around the press site here getting their cameras and tripods ready to capture this Falcon 9 rocket as it makes its ascent from Florida's Space Coast. Coming up in the next minute, we should hear a call regarding the engine chill. SpaceX will flow a small amount of liquid oxygen through the plumbing and turbo pumps, helping to protect those engines from the risk of thermal shock and damage during startup. That call should happen right about T-minus 7 minutes or thereabouts. Also worth noting, the SWIFO L1 mission does have a designed baseline life of 5 years, but like with IMAP and with Carruthers, it is also expected to last well beyond that with a good liftoff that preserves its propellant.
Engine chill has started.
Good call regarding engine chill. Next call we should hear over the nets will be in regard to first stage RP1 loading being complete. That should happen right about T-minus 6 minutes.
Stage 1 RP1 load complete.
There's that good call out regarding first stage RP1 loading. Coming up next, the next call out we should hear should be regarding the tanks pressurizing for the start of the reclining of the strongback. We'll hear that call a little bit past the 5-minute mark.
Tanks are pressing for strongback retract.
A good call out there. The strongback retract sequence should begin in earnest in about 10-ish seconds. First, we'll see the clamp arms just beneath the payload fairings open up, and then the strongback will recline a few degrees away from the Falcon 9 rocket.
Strongback retract has started.
NLM, this is LD on countdown 1 with a status check.
this is NLM. NASA's go for launch.
And a good go for launch call from NASA. Launch Services Program, or LSP, managed here at the Kennedy Space Center. With the NASA side of the coin good to go, we're now coming up to the final bits of the fueling process. In roughly 30 seconds, we should hear a call that first stage LOX load is complete. Same will be true on the second stage at about the 2-minute marker.
Stage 1 LOX load is complete.
And a good fueling call there. Less than 3 minutes on the clock. Taking a quick peek at our chat. Want to thank the more than 5,100 of you who are joining with us live. If you haven't already, certainly appreciate it if you could hit that like button, share the stream so more folks can find their way in at these final few minutes of the count. Should be a very spectacular sunrise launch in just about 2 minutes. Also want to quickly thank our moderator, Aussie Space Girl, for joining us from down in Australia. Thanks to Ray Rose for a $2 Australian super chat.
Stage 2 LOX load is complete.
With that call, the Falcon 9 rocket is now fully loaded with 1 million pounds of propellant. As we come up to the 1 minute mark in the count, you're seeing now the ground gas closeouts. SpaceX releases the remaining liquid oxygen from the feed lines there at the pad.
Ground gas closeouts.
There's that call confirming that. Want to quickly thank as well K2 Hat for a $5 super chat. Thank you, K2, who says, "Good morning from Miko. Thanks for the coverage. As always, great job." Appreciate the kind words. Appreciate you being here as we're now approaching the final minute of the count, and our attention will be squarely focused on the rocket as we're looking for the start of the automated sequence of the Falcon 9.
Falcon 9 is in startup.
And with that good call, we are now just awaiting the SpaceX launch director to give their call that they are, in fact, as well, go for launch. That's coming in the next few seconds.
The launch director is go for launch.
And a good confirmation that things are progressing as expected. That go for launch call means we are now just a little more than 30 seconds away from the flight of this Falcon 9 rocket. And these key heliophysics missions heading up on their way to Lagrange point 1, a million miles from Earth. 20 seconds and counting. 15 seconds. And here we go in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition and liftoff. Liftoff of the Falcon 9 rocket on the IMAP rideshare, getting ready to explore the sun and the heliosphere and all it contains. And a beautiful solar transit. Well done to our Michael Caine for that shot. Everything progressing nominally with the Falcon 9 rocket as we're coming up on a minute into the count. The rocket is approaching max Q, the point of greatest aerodynamic pressure on the vehicle. It'll throttle back on its main engines as it's now passing the speed of sound. Coming up on max Q now. Now passing through max Q, the rocket will throttle back up on the 9 Merlin engines at the base of the booster. About a minute and a half into this mission. Coming up next will be the thermal conditioning of the Merlin vacuum engine on the rocket's second stage. Confirmation of MVAC chill. We're coming up to a few events in fairly rapid succession. We'll see first stage main engine cutoff, or MECO, at about T plus 2 minutes and 29 seconds. That'll be followed by stage separation at 2 minutes 32 seconds. And then the Merlin vacuum engine on the second stage will ignite for the start of its first burn at about T plus 2 minutes and 40 seconds. The payload fairings will jettison a little more than 3 minutes into this flight. For about 10 seconds to MECO. MECO. Stage separation. And second stage engine start. Really nice visuals. Good job by the tracking team. A little more than 3 minutes into the mission, we're coming up on fairing separation momentarily. And the fairings have been deployed. A good view briefly of the 3 spacecraft. As you can see, one of those fairing halves making its way back down to the waters of the Atlantic Ocean. It'll splash down under the support of steerable parachutes once it's back through the atmosphere. So far, a very by-the-books flight as we're coming up on 4 minutes into the mission. Coming up next will be the start of the first stage entry burn, which will begin at roughly T plus 6 minutes and 37 seconds. That'll call upon 3 out of the 9 Merlin engines at the base of the booster to begin to slow that part of the vehicle down. Burn should wrap up just a little past T plus 7 minutes into flight. Coming up to 5 minutes in the flight. We still have a bead on the Falcon booster, but it is behind quite a bit of clouds from our camera's vantage points, so not super confident that we'll get the start of the entry burn with our tracking cameras, but we are still seeing those puffs of the cold gas thrusters on the booster, which help it adjust its attitude or positioning as it orients itself towards the drone ship called Just Read the Instructions, waiting for it out in the waters of the Atlantic Ocean. Of course, if we are able to catch that entry burn, we'll bring that to you. It's set to begin now in less than 1 minute. Coming up on the start of that entry burn here in less than 10 seconds.
Stage 1 entry burn startup.
Stage 1 FTS is saved.
Good calls there. The second one was regarding the FTS, or the flight termination system of the booster. Safety mechanism no longer needed at this point in the mission.
Stage 1 entry burn shutdown.
With the conclusion of that entry burn, next up will actually be the conclusion
Stage 2
of
is in terminal guidance.
the burn on the second stage, which is what that call out was just regarding. Stage 2 entering terminal guidance is the call that comes just prior to the upper stage wrapping up a burn that it's in.
Stage 2 FTS is saved.
Good call there. Engine cutoff should happen momentarily.
Stage 1 transonic.
MVAC shutdown.
Some good call outs there. The first stage booster now traveling below the speed of sound, and the upper stage now entering into the start of its
Nominal
coast
park
phase.
orbit.
And a good parking orbit to boot. Coming up on the start of the landing burn here in the next few seconds.
Stage 1 landing burn.
Is set to be the second landing for this particular Falcon 9 first stage, B1096.
Landing leg deploy. Stage 1 landing confirmed.
And a good touchdown for this booster, having now made its second trip to space and back, following its launch of the Kuiper Falcon 1 mission earlier in the summer. And a really nice view of the spacecraft that are on board this Falcon 9 rocket. Now, a little more than 9 minutes into the mission. At this point, the rocket, or the upper stage of the rocket, will remain in a coast phase until T plus 1 hour, 12 minutes, and 28 seconds. There will be a roughly 1 minute burn to help put the rocket on the correct trajectory ahead of the deployment sequence beginning. And that will start at T plus 1 hour, 23 minutes, and 51 seconds post liftoff. Again, we will start by seeing the deployment of the IMAP spacecraft. That'll be followed by the deployment of NOAA's SWIFO L1, and then finally wrapping things up with the jettisoning of the Carruthers Geocorona Observatory at T plus 1 hour and 36 minutes into the mission. Time now T plus 11 minutes, 37 seconds and counting. It has been a smooth and nominal flight of this Falcon 9 rocket so far. As you can see, the upper stage is just about over the middle of the Atlantic Ocean, heading towards the west tip of the continent of Africa. Going to do something a little unusual for one of our broadcasts. I'm actually going to be stepping away from the mic and we're going to do our own handover here at Spaceflight Now, and I'll be passing you off to the very good hands of our editor, Stephen Young. So I'll bring in Stephen now. Stephen, how are you this morning?
I'm doing good. How are you, Will?
Good. It is still dark here at Houston, a few miles away from the Johnson Space Center. The reason that I'm here, of course, and not in Florida with the rest of our team is today is the second of a 2-day very thorough debrief on the upcoming Artemis 2 mission. Today's the day where we're going to be hearing directly from the astronauts themselves. So looking forward to hearing that panel, and then we'll also be sitting down one-on-one with astronauts Victor Glover, who is the NASA astronaut in the pilot's position, and Christina Cook, who will be one of the mission specialists flying aboard the Artemis 2 mission next year.
Well, it sounds like you've already had a very packed visit to the Johnson Space Center. What are you looking forward to hearing today from the crew?
Well, so yesterday, just to give a quick snap recap of what we learned and saw for those of you who were able to follow on our social media, we got a really robust and as detailed as we've gotten overview of the mission, the milestones, the science that'll be happening from the really the point we're at right now, the preparations of the SLS rocket and Orion spacecraft currently in its final flow before final stacking at the VAB. That's all going well. Orion should be integrated sometime next week onto the top of the stack. And then we got a little bit of an overview of what the rest of this year is going to look like with the rocket on the mobile launcher that'll head out to the pad. Unlike last time with the Artemis 1 mission back in 2022, the plan is for the rocket to roll out once, and once it's at the pad, it'll go through its final checkouts, communications between the rocket and the mobile launcher, the ground infrastructure out of the pad. The crew, because this is the first crewed mission, will also be doing their first walk down with the rocket at Launch Complex 39B and checking out some of the systems like the emergency egress system, which wasn't a factor for Artemis 1 since there was no crew to egress during that launch campaign. And so we'll see them go through those final operations there at the pad, the wet dress rehearsal, of course, the tanking of the rocket, making sure that teams are familiarized once again with the flow of loading the vehicle with liquid oxygen and liquid hydrogen. And then they'll get into their launch campaign with a liftoff currently planned for no earlier than February 5th, as we also just learned officially yesterday. So today, what I'm looking forward to hearing is, hearing directly from these 4 astronauts, 3 NASA astronauts, 1 Canadian Space Agency astronaut, about, how tangible this is becoming for them, what the final months of training are looking like now that there's a more refined launch date that they are targeting, and what's going to be on their docket. Sounds like we're hearing a call over the nets. Let's listen for a second.
Well, it sounds like exciting times ahead. You need to get off and get ready for that. So thank you for your commentary this morning, and I'll take the audience through the remainder of the mission.
Appreciate you taking the baton, Stephen, and for our viewers, you're in very good and capable hands. So hope you stick around for the next about hour and 15 minutes as we've got some good videos to show with you. Obviously, the mission still progresses, and so we've got a lot more to touch on, including look back at the liftoff itself, which we'll be getting into flow very shortly. So thanks for sticking with us, and be sure to both subscribe to the YouTube channel here, follow us on social media, as I'll have updates throughout the day, throughout the course of our conversations with the astronauts coming up here in the latter part of the morning and throughout the afternoon. Also looking forward to talking with some of the flight directors and seeing the Mission Control Center, which following Orion's separation from the interim cryogenic propulsion stage, the upper stage of the SLS rocket, that's when things will hand over to JSC from KSC, and the mission will get underway. Obviously, some very notable, exciting points of operation coming up within the first day of launch. Teams will do a full checkout of the Orion spacecraft to make sure all of the life support systems are working as expected, that there are no show-stopping technical issues with the vehicle, and that includes some, big things that you might think of, like that all the engines and thrusters are working as expected. They'll do a proximity operation with the ICPS, and also some things that you might not think of but are very critically important when you're talking about a 10-day mission for this crew. Things like making sure that the toilet is in full working order, and that there aren't any things like that that would be potentially showstoppers and cause them to pivot the mission. There are a number of different abort scenarios, which we'll be talking more about as we get closer to launch. But in a super off-nominal scenario, for example, if they feel like they are just not in a position to do the translunar injection burn, the TLI burn, if they have not gotten into the highly elliptical orbit, they can do a mission in low Earth orbit and run Orion through its paces with crew on board. They would get quite a bit of good data from that. Obviously, the moon objectives would be lost in that scenario, and that is, of course, very much not the operational plan, but they are going through all the various contingencies, both with the flight director team, with the crew, and all of the ground support as well. So looking forward to bringing you a robust suite of stories coming out of here in Houston and at the Johnson Space Center.
Well, thank you, Will, and good luck with your coverage today. And sounds like you've been drinking from a fire hose the last day or so, and yet more to come.
It's a good thing. There's plenty of good water to drink. It's all very exciting, very informative, and it's the things we love to learn about, and we'd love to share it with you all. So looking forward to that. Thanks, Stephen. I'll hand things off to you.
Thanks, Will. So we're now 20 minutes into the flight of the Falcon 9, the second stage, just about to cross the coast of Africa as it's made its way across the Atlantic. The next major event in the countdown will be the restart of that second stage, the Merlin vacuum engine on the second stage, now just over 30 minutes away. This will be just under or just over a 1 minute, 2-second burn for that engine. The deployment of the first satellite, IMAP, will occur 10 minutes after that burn is complete. And then we will see the deployment of the space weather follow-on Lagrange 1. And then the Carruthers Geocorona Observatory will be released from the upstage of the Falcon 9. although Will's had to leave us to get ready for those briefings at the Johnson Space Center, we do actually have a few packages that we'll put together prior to this mission to explain what exactly is going on with these satellites that are sharing the Falcon 9 on this ride to the Lagrange point. So let's go ahead and to start with, listen to Will's explainer on the IMAP mission.
This may be an obvious statement, but there's a lot we don't know about our galaxy. That's not exactly a hot take. While we want to learn more about the Milky Way galaxy and beyond, it helps to better understand our own celestial backyard as well. In this case, I'm talking about the impacts of our own sun. It has a vast sphere of influence, both figuratively and quite literally. There's a constantly changing magnetic bubble protecting our solar system called the heliosphere. NASA has a spacecraft called IMAP, or the Interstellar Mapping and Acceleration Probe, that's set to study the heliosphere and create the first complete map of it. Before diving into the spacecraft itself, though, we asked IMAP principal investigator David McComas to give us an understanding of the heliosphere itself.
So the heliosphere is basically a pressure balance between pressure outside the heliosphere and pressure from inside the heliosphere. On the outside, there's a dynamic pressure, just like when you drive your car through the air, it pushes back on your car. The faster you go, the more energy it takes to push the car through the air. There's also a magnetic field that wraps around the heliosphere and provides an asymmetric pressure. On the inside, the solar wind, million-mile-an-hour solar wind that's blowing out all directions in space all the time, inflates it from the inside and provides the pressure from the inside out. And where those two pressures match, you basically get the boundary between the two, the stuff from inside, solar material, and the stuff from outside, galactic material. The sun changes over the course of the solar cycle and over time, and so it blows more and less hard. And so this outer boundary also moves as the sun's pressure changes.
Those following the study of heliophysics may recognize Dr. McComas. IMAP is actually his third time as a principal investigator. He was a PI on the Interstellar Boundary Explorer, or IBEX.
Go for drop.
The predecessor to IMAP, which launched back in 2008.
It's a very small satellite, about 10% of the mass of this much larger spacecraft. It only had 2 sensors on it instead of 10 instruments. But it made some of the first energetic neutral atom imaging of the outer heliosphere and proved that it was possible and made some of the initial discoveries. And it was based on all of the great science that came out of the early years of IBEX that basically the heliophysics community came together around this new mission called IMAP to do this much bigger, grander version where we're able to take much higher sensitivity observations, and combining that with all the in situ observations and being able to do the full life cycle of these solar particles going out past L1, causing space weather, going to the outer heliosphere, interacting, and then some of them coming back in as neutral atoms. It's really a holistic scientific path that was built on this much smaller mission.
IMAP was selected for maturation into a full mission in June 2018. It's gone through a barrage of tests in order to ensure that it can withstand the rigors of launch and operation in deep space. From spin balancing tests at the Johns Hopkins Applied Physics Lab in Maryland, to a 28-day stay in a thermal vacuum chamber at the Marshall Space Flight Center in Alabama. We got to see it during the last leg of its journey here on Earth at the Astrotech Space Operations Facility in Titusville, Florida. NASA invited members of the press to see the spacecraft along with NOAA's SWIFO-1 and the Carruthers Geocorona Observatory. We'll talk more about those two in separate videos. For the sake of this conversation, though, they're the two rideshare spacecraft that will be joining IMAP on a multi-month journey to their operating location, a gravitationally stable point in space about 1 million miles from Earth, in between the Earth and the Sun, called Lagrange Point 1.
Yeah, so L1 is great. I already mentioned that IBEX was the predecessor of IMAP. IBEX is in Earth orbit, and most of the backgrounds we have that limit our ability to do the ENA imaging have to do with the Earth's magnetosphere. And so getting far away from that was one critical point. We also wanted to be important for space weather, so we wanted to be upstream of the Earth. The L1 is the natural location for that. And the fact that it goes around the Sun with the Earth so that you get full coverage every 6 months, just like you would in Earth orbit, sort of made that the clincher. It's also, for a bunch of engineering reasons, a pretty nice place to fly. It's very stable. You have a sun-pointed spinner like IMAP. You're always broadcasting aft towards the Earth. So it's good for a bunch of science reasons and for engineering reasons.
McComas and his team are planning to turn on all 10 of IMAP's instruments before the end of 2025 and begin what he calls a science demo phase.
It's still before we get to L1, but we'd like to run in full normal science mode and make sure that it's exactly the way we want to be running. And then we burn in, I think it's January, I forget the exact date, but we burn in January and we go into this orbit about L1. Once we've proven that that's good, we move out of what's called phase D by NASA, which goes through launch and commissioning and orbit insertion. We go into phase E, which is the science phase, where we basically run this simple repetitive mission to take all this great data with our 10 instruments.
Let's go back into the clean room to talk about the instruments and the spacecraft itself. For a sense of scale, this spacecraft is about 3 feet or 0.9 meters tall and is about 8 feet or 2.4 meters in diameter. Just a minute ago, you may recall McComas mentioned space weather. It's a term used to encompass the effects of the sun on the solar system. Those are things like solar flares, coronal mass ejections, and the release of particles dubbed the solar wind. Of the 10 instruments on board, 6 of them are keenly designed to study both short-term and long-term space weather.
The short-term regular space weather has to do with the sun, things that come off. They take hours to days to get to the Earth and have an impact. But the entire heliosphere provides shielding for these galactic cosmic rays. And if you want to send astronauts to Mars, for example, they spend many months out in free space, away from the Earth's magnetosphere, largely unprotected because you can't fly enough protection around them to completely shield out these galactic cosmic rays. Well, it turns out that those galactic cosmic rays vary over the solar cycle because the shielding in the outer boundaries of the heliosphere varies. And so understanding that interaction better will make us better able to predict what the real risk assessment would be for astronauts traveling on their way to Mars. And so that's sort of the long-term space weather, space climate. Also really important for humanity.
To achieve that holistic understanding, 3 of those instruments, the Solar Wind and Pickup Ions, or SWAPI, the Compact Dual Ion Composition Experiment, or CODIS, and the High Energy Ion Telescope, or HIT, will study the solar wind and other energetic ions as they head out away from the sun. Meanwhile, the IMAP Low, the IMAP High, and the IMAP Ultra instruments track energetic neutral atoms that reach all the way out to the edge of the heliosphere and are bounced all the way back to IMAP.
So we wanted to have 2 sets of instruments, a set of instruments that measured the ions coming out from the sun, from the solar wind at low energies all the way up to superthermals and energetic particles. And then they go out, they interact in some fraction, come back as energetic neutral atoms. We wanted to be able to cover the entire same energy range of those particles coming back so that we got the full life cycle of the particles. And that's what drove 3 of each.
Most of the other instruments are also studying various aspects of the sun. The Global Wind Structure, or GLOWS instrument, is investigating the glow generated by solar wind and how it evolves over time. The solar wind electron, or SWE, will measure the electrons found within that solar wind. And the magnetometer on top of the spacecraft, which will deploy once in space, is designed to measure the interplanetary magnetic field created by the sun. But the 10th and largest instrument, called IDEX, or the Interstellar Dust Experiment, isn't studying the sun specifically. Rather, as the name suggests, it's designed to collect and study more interstellar dust in the course of just about a year than in the rest of the 50-plus years of space exploration put together.
It's really quite extraordinary. It not just measures the dust and the dust size and velocity, but actually the dust impacts a gold surface inside on the bottom. It gets vaporized, and we sample the material coming off of it. And that allows us to tell what it's made of. So we're not just learning about the size distribution of dust or the speed distribution of dust, but we're actually learning about the composition of each of these individual dust grains. So we're trying to understand what this interstellar dust is and what its origin is. It probably comes from exploded stars, nova and supernova, other stars in our galaxy that lived a long time ago, exploded, spread some of their material around. Could be coming partially from the grinding up of planets or planetesimals or that sort of thing. Not much is known about it because very few dust grains have been directly sampled. So it's a real opportunity to learn about the stuff of the other stars and how it sort of makes its way into our own heliosphere over time and what it tells us about the galaxy at large.
IMAP has a life cycle cost of $781.8 million. That includes development, launch costs, and the planned 2-year prime science mission. NASA booked SpaceX's Falcon 9 rocket for $109.4 million, which will feature not only IMAP, but also the Carruthers Geocorona Observatory, another NASA mission, and the space weather follow-on Lagrange 1 or SWIFO L1 spacecraft from NOAA.
Because of the uniqueness of this ride, we wanted to make sure to take advantage of that. That's why our partners at NOAA, as well as our ability to bring Carruthers along with the IMAP mission, is really valuable. We had an early mission that was along for the ride that didn't quite make it, wasn't quite ready in time. A technology development mission for solar sails. A lot of that work has continued forward, and hopefully we'll be able to get a ride in the future.
As mentioned, IMAP is slated for a 2-year nominal science mission, but like with many other NASA spacecraft, there's a good chance that it could be collecting quality science data for quite a bit longer than that.
We have expendables on board for at least 5 years, guaranteed. And if we get anything close to a nominal launch, we'll have lots of gas that we could go for many decades. IBEX, which was a small explorer and built to a lower quality standard and all of that, just because it was an inexpensive mission, is still functioning 17 years after launch, still functioning today. We hope it'll be functioning when we get IMAP up, and we'll be able to cross-calibrate between the two in space, taking observations, looking the same direction at the same time, and be able to take the whole 17-year data set from IBEX and link it into this much more sensitive and accurate set of measurements from IMAP. So if you can do that with the SMEX, we hope to be able to run IMAP for decades, to be honest.
And as IMAP is with us potentially for decades to come, McComas says among the things he's most looking forward to are the discoveries that no one could have predicted.
Yeah, so as an experimental space physicist, the most exciting thing is you design the instruments, you design the mission, you want to measure something that's not been measured before, or you want to measure something much better than it's been measured before, and you do all that work, you build it, you qualify it, you get it on a spacecraft, you launch the spacecraft, you commission it in space, you get the science data back, and then you learn a lot of stuff from that. You write a lot of great science papers, and you go all the way full circle, and you try to figure out how to make the measurements better. That's the process we've run through IBEX and now into IMAP. And so it's really exciting to get the entire life cycle and to be able to basically steer the field and the science in the field by making the right observation.
That was Will reporting from his visit to the clean room where the IMAP mission was being prepared for launch. That video is also available as a standalone video if you wanted to go back and watch anything that you might have missed in that clip. So we're now 35.5 minutes into the flight of the Falcon 9, the second stage, now traveling across Africa, about to head out over the Indian Ocean and the island of Madagascar. We're getting ready some launch replays, including a view of the solar transit where the Falcon 9 rocket passed in front of the sun, so stay tuned for that. While we wait for those replays to be ready, we have also got another video that Will prepared earlier on the space weather follow-on Lagrange 1 mission. Let's run that tape now.
Our lives are increasingly dependent on technology to work, from the way we travel to how we grow food, and of course, the device you're watching this on. But the more tech that's in our lives, the more susceptible we are to the whims of the sun.
The different industries have different ways of responding. For example, the power grids have to be concerned about the potential that energy will enter the grid and create a bias that could overwhelm the transformers. Aviation is impacted primarily because the long-range communications using high-frequency radio relies on the state of the ionosphere. And the ionosphere is disturbed by these space weather storms, which means that those high-frequency communications are disrupted.
Space weather is how researchers and forecasters describe the various impacts of the sun. Those include violent eruptions called coronal mass ejections. They can interfere with satellites, power grids, and even impact astronaut safety. That's where this latest satellite from the National Oceanic and Atmospheric Administration comes in. It's called the Space Weather Follow-on Lagrange 1, or SWIFO-L1 for short. It's the first NOAA spacecraft purpose-built as an early warning system for space weather. The Lagrange 1 in its name is where the satellite will operate. L1 is a stable, fixed point in space, about 1 million miles away from Earth, that sits between our planet and the Sun. Richard Ullman, the director of NOAA's Space Weather Observations Office, picks it up from there.
When an event comes off the sun, a coronal mass ejection, depending on how fast it is, and of course the track, whether it's coming towards the Earth, it could be a super fast one is 12 hours. More typical is 2 to 3 days. So we get a couple days warning. But we don't actually know how strong that storm is until we see it at the Lagrange point 1. 1 million miles is a far distance, but remember the sun is 93 million miles from Earth. So at these speeds, what that means is we have about 15 to 45 minute warning of exactly how strong that is.
That may not seem like a lot of time in the grand scheme of things, but it could make a big difference to key industries. Let's go back to Ullman's example of power companies.
So they get a couple, from 12 hours to 2 to 3 days warning, something might be coming. And so at that point, they might choose to delay maintenance or change their staffing profile. But then at the few moments before, they're able to get how strong we think this is going to be and perhaps even what regions of the Earth it might impact. And so then they can take preventative actions to perhaps turn off sections of the grid or be prepared for these potential overloads.
Dr. Joseph Westlake is the director of NASA's Science Mission Directorate's Heliophysics Division. He pointed to the solar storms of 2024, which provided unusually widespread views of the auroras as a key turning point for folks. Westlake says that event brought the impacts of the sun down to earth for a lot of people, both the beauty and the potential economic impacts.
You know, we found for the first time that agriculture in the Midwest has been affected by space weather. I never thought that I would be in a conversation with some of our agriculture folks as a heliophysicist thinking about, you know, how the sun impacts us when they say, oh, you know, my GPS systems, my precision location systems were affected by the May solar storms, and I missed part of the planting season because my systems were inoperable for that time. It's the first time we have seen that. As the American public becomes more and more technologically savvy, as we become more and more reliant on things like GPS and space-based communications, I think it becomes more and more of a reality that every company is now a space weather company. Every industry now is affected by space weather, and every American is affected by these impacts.
But SWIFO isn't flying solo. It's hitching a ride to Lagrange point 1 alongside NASA's Interstellar Mapping and Acceleration Probe, or IMAP, and the Carruthers Geocorona Observatory. Both spacecraft have their own unique missions studying the impact of the sun. Following launch, the trio will take the rest of the year to make the trip out to L1, arriving around January 2026. Ullman says that SWIFO should be finished with its calibration and commissioning by early next year, and he expects it to be fully operational in the spring.
Unlike the other satellites that are being launched, the IMAP and Carruthers, which are science missions, they're research science missions, we are a science application mission. So we are looking at the same phenomena for the application of being prepared for the space weather that's going to impact us. We're hoping that these IMAP and Carruthers will improve our knowledge and make us able to make better forecasts. But what we're doing here is the operational forecast, the day-to-day.
The spacecraft itself was built by BAE Systems in Colorado and features a suite of 4 science instruments. Spaceflight Now was able to see the SWIFO L1 up close after it finished its fueling campaign last August. Dr. Dimitrios Vassialdis, the SWIFO scientist and former NASA research scientist, gave an overview of the spacecraft's instruments.
The most visible part is the magnetometer boom. That's a large cylinder that you see on your left. That will extend all the way to 15 meters, 5 meters, 15 feet out, and that will measure the magnetic field as it's streaming past the spacecraft. Then we have additional instruments such as 3 imaging/sensor instruments. One of them is a telescope that looks at the sun, and that in particular looks at the solar corona. And 2 others are particle sensors. These are on the opposite side, so they're not exactly visible, but you can think of them as also pointing towards the sun. They will measure the plasma as it streams also past the spacecraft, and the particles that are also emitted from the sun.
The SWIFO L1 spacecraft is designed with a 5-year mission in mind, but it has enough fuel on board to potentially operate for a decade or more. Ullman says Congress approved $692.8 million for the total mission cost. That includes $635 million for the spacecraft itself, as well as another coronagraph that launched on the GOES East satellite back in June 2024. The cost also extends out to the ground elements that will be used here as well as on successor missions. One of those is already in the works. It's called Vigil, and it will operate at Lagrange Point 5 through a partnership with the European Space Agency.
Our contribution to the Vigil mission as a part of our partnership is a coronagraph, same model coronagraph that we have on SWIFO. And so that will give us a stereoscopic view of those coronal mass ejections. L5 is behind Earth, 60 degrees. L4 is 60 degrees the other direction. When we're looking at a stereoscopic view, it really doesn't matter which direction, which side we're looking at. We want a side view. L5 is got some advantages, being able to see sunspots and things before they rotate into pointing at the Earth. L4 has other advantages, but L5 is the next opportunity, and that's why we're going there.
While ESA won't be launching the Vigil mission until 2031, Ullman says NOAA is already working on the successor to both it and SWIFO.
We're also have already started the next iteration of the same observing capabilities with what we are calling the Solar Project, which is the next 2 spacecraft that are like SWIFO to go to the Lagrange Point 1. The first of those is planned to be launched in 2029. And at that point, that gives us more resiliency on the really important Sun-Earth line, and it provides for continuity into the future.
Ullman says he and the NOAA team are excited to finally be on the cusp of launching about 5 years after this mission was first conceived. He says this will be a critical service for not only those in the United States, but also to others around the world.
We get the data down within 5 minutes for solar weather, and within 15 minutes or 30 minutes for the coronal mass ejections. That operational cadence is well improved from the historic legacy research missions, which had a very different purpose, which was basic research. It's important to know that NOAA is committed to space weather observation and making sure that the nation is prepared for those events that come from the sun that affect our lives and our economies.
And a big thank you to Will for putting together those packages. As you can see from the countdown clock at the Kennedy Space Center press site, we're now 46 minutes and 18 seconds into the flight of the IMAP mission. The second stage is now approaching the midway point across the Indian Ocean as it heads on a track that will take it across Australia. The next major event in the mission will be the reignition of the second stage Merlin vacuum engine. That's coming up at the 1 hour, 12 minute, 28 second mark in the T+ count. We will have replays of the launch coming up soon. But before then, we're going to take a look at the third spacecraft on this mission. the Carruthers Geocorona Observatory. Once again, Will has put together this explainer on the mission, and we'll run that video now.
How are Apollo 16, the University of Illinois, and one of NASA's small Explorer missions related? Stick around, I'll explain. As a planet, we are living in a pretty windy neighborhood. The sun is constantly emitting solar wind, streams of electrically charged particles that reach across the solar system. NASA's Parker Solar Probe was able to image the solar wind during a close encounter back in November of 2018. Thankfully, Earth has an atmosphere that largely shields us from this solar wind, but beyond the most commonly known layers lies the outermost layer. It's called the exosphere or the Geocorona, but there's a lot we don't know about it. We haven't even been able to get a full picture of it to know how large it is. That is, until now. NASA has a new spacecraft called the Carruthers Geocorona Observatory that will fly 1 million miles from Earth to a gravitationally stable point between the Earth and the Sun called Lagrange Point 1. From that vantage point, researchers are hoping to learn more about the basics of the Geocorona. Carruthers is 206 kilograms or 454 pounds unfueled and 241 kilograms or 531 pounds loaded up with hydrazine. For scale, NASA says it's roughly the size of a love seat. We met up with Carruthers' principal investigator, Dr. Laura Waldrop, inside the clean room in Florida where the spacecraft was undergoing final preparations to learn more.
If you look behind me, that's the Carruthers spacecraft, and mounted on the top deck above the spacecraft bus that contains things like the telemetry and the power and propulsion. That's the top deck, and then up there is our instrument. And our instrument is 2 cameras. They both measure in the ultraviolet. On the left is what we call the narrow field imager. It takes pictures close up near the surface of the Earth at high resolution. We get an image every 30 minutes. And then on the right is the wide field imager. And the wide field imager is a wide field. Our goal is to capture the entire exosphere in one picture. And we'll be returning those pictures every hour for the life of the mission.
The mission is expected to last at least 2 years, but with a good launch, Carruthers is poised to operate for decades. The spacecraft will be able to image the corona because there's a faint light emitted from the hydrogen atoms within this layer of the atmosphere.
So by measuring the density of the hydrogen atoms that are emitting the glow that we're imaging with these cameras, we'll be able to determine things like the escape rate of the hydrogen atoms as they leave our planet. These are the hydrogen atoms that originated from surface water that became water vapor, and now they essentially evaporate off into space. And then that's what will inform our understanding of how this process works on Mars and other planetary bodies.
According to NASA, there are only 4 images of our planet's exosphere that have ever been taken. So how did we even know to go and try and study this outer atmospheric layer? Well, that's where both Apollo 16 and the University of Illinois come in through one man, Dr. George R. Carruthers. Born in Cincinnati, Ohio, Dr. Carruthers was a 3-time graduate of the University of Illinois. Between 1961 and 1964, he earned a Bachelor of Science in Physics, a Master's in Nuclear Engineering, and a PhD in Aeronautical and Astronautical Engineering. He became the first E.O. Holbert Postdoctoral Fellow of the U.S. Naval Research Laboratory in 1964 and got a full-time position there in 1967. Dr. Carruthers proposed an ultraviolet imaging experiment for the Apollo program, and that became the Far Ultraviolet Camera/Spectrograph. This gold-plated instrument seen here was one of 4 developed for testing, and on April 20th, 1972,
we have a launch commit and we have a liftoff.
One of them was launched to the moon as part of the Apollo 16 mission. Once on the lunar surface, astronaut John Young set up the telescope in a region of the moon called the Descartes Highlands. It became the first telescope ever set up on another planetary body.
Houston, the Earth is maybe a quart. It's right in the middle. Outstanding. You did a good down center alignment.
And it also gave us our first picture of what Dr. Carruthers dubbed the Geocorona. That's why this upcoming mission, led by University of Illinois faculty, bears the name of one of their most esteemed alumni.
Oh, it's such a privilege. You know, I referenced his work in the original proposal, not knowing that he was a University of Illinois alum. And this is University of Illinois' first NASA mission. It's incredibly exciting, but especially to know that he designed the first ultraviolet imaging system. It's still on the moon, and here we are about to launch cameras that use his technology, and we're going to be deploying those into deep space to acquire. He acquired a few images. We'll be getting a few every hour.
The Carruthers mission comes with a $97 million price tag for the full life cycle. It's hitching a ride out to Lagrange Point 1 alongside another NASA mission called the Interstellar Mapping and Acceleration Probe, or IMAP, and the space weather follow-on Lagrange 1, or SWIFO L1, from NOAA.
Once Carruthers arrives at L1, it'll go through a commissioning phase, or basically like a test drive. That'll take around 6 months in order to make sure everything is right, and then the data will be released after those 6 months. After that, it'll be more like daily that we will get the images down from Carruthers.
Carruthers will be the first spacecraft placed far enough from Earth to be able to get a full picture of the entire Geocorona. Right now, scientists aren't even entirely sure of its size or shape.
I think instantly when we start taking images, we will see the size. However, I think the size also is going to vary. I think with all the space weather we have, the influence of the solar wind, we're going to see a variable exosphere. So that might change when a huge coronal mass ejection comes by. It might morph into shapes. So I think we'll get a baseline shape very, very early, but then it'll also be interesting to watch it over its 2-year mission as to how it changes.
That collection of images will allow researchers to see the Geocorona as it shifts in a movie-like fashion. And getting a better understanding of this outermost layer will help all of us understand the big impact of solar weather on our planet and our infrastructure.
So why this mission is so important right now is because of space weather. We've become so dependent on our technology, on satellites, and as we explore and go to the moon and Mars, we really need to know what the weather report is out there. And so as these space weather events come through, they interact with the exosphere, that first outer part of the atmosphere. And that atmosphere can actually take some of that energy away. So basically calm it down and maybe not have any of those effects on Earth. So we really need to understand how that's going to react. When can it dissipate energy? When can it kind of stop the thunderstorm from happening versus when it can't actually stop that energy, and that energy is going to come to us and could affect our power grids or maybe our GPS or even our agriculture and our planting or tractors.
And thanks again to Will for that explainer on the Carruthers mission. We're now 55 minutes into the flight of the Falcon 9. The upper stage has just crossed the west coast of Australia, as we are approximately a little... let me just make sure I've got the right time in front of me here. We're currently about 16 minutes and 30 seconds from that burn of the Merlin vacuum engine on the second stage. Coming up, SpaceX will perform a chill down of that engine prior to the ignition. We're just about ready to play our launch replays, which includes the Falcon 9 rocket passing in front of the sun, captured by our photographer Michael Kane. So stay tuned for that. That's coming up momentarily. So we'll start our replays with a wide view captured by Adam Bernstein from the press site. And now a view from the camera overlooking the turn basin here at the press site. And now for the solar transit, not an easy shot to get, but Michael Caine nailed it today. Now we turn to Pete Carson's tracker, south of the pad. Nice shock collar on the nose cone there. Fortunately, there was some cloud in the area from Pete's perspective. From this angle, you can really see how the plume of the Falcon 9's first stage, the 9 Merlin engines, expands as the rocket climbs through the atmosphere into lower pressure. With this easterly trajectory, Pete was really able to capture the separation of the first and second stages, so watch out for that. And there they go. And you see the ignition of the second stage. Also starting to see those cold gas thrusters working on the first stage as it prepares to descend to the drone ship. Great work as always by Pete, keeping the vehicle in the sights of his camera. There goes the payload fairing. Those two payload fairing halves will be recovered from the Atlantic. I believe they are brand new, being used for the first time on this mission. And then we switch over to Pete's wider view. Always like this view as it appears over the top of a palm tree from Pete's perspective. Contrail formed while the vehicle's going through max Q, the period of maximum dynamic pressure on the vehicle. That's a combination of the rocket's acceleration and the atmospheric density. The acceleration is always increasing, but the atmospheric density falls as the rocket climbs higher. So the point of most pressure on the vehicle occurs fairly early on in flight. On today's mission at about 1 minute, 12 seconds. You can really see how that plume has expanded with the climb of the Falcon 9. Here we see cutoff of the first stage and separation and ignition of the second stage. See the change in plume as that second stage engine fires up. And the cold gas thrusters on the first stage putting on quite a show with the lighting conditions with this launch coming soon after sunrise today. Once again, great work by Pete, keeping both the first and second stages in that view. Coming up next, Chuck and Jen Briggs' tracking camera, which was located here at the Kennedy Space Center today. Really impressive to see all those vapors streaming down the rocket as it climbs away from the pad. Excellent view from Chuck here. You can actually make out the mission logos on the payload fairing there. There's that shock collar. Very impressive from this angle. And finally, we'll take a look at Adam Bernstein's tracking view from the press site from outside our building at the Kennedy Space Center. You can hear some of the people assembled to view the launch, whooping and hollering. And here comes the sound. There's that shock collar traveling down the vehicle. Adam just reacquiring. Really nice to see the color in the plume as it expands. Not quite as visible as it is at night, but you could still see those colors forming. A big thank you to Adam for not only operating the tracking camera today, but setting up a lot of our other cameras that we used in the course of the broadcast. So we're coming up on that second stage burn as the Falcon 9 second stage heads out over the Pacific Ocean. You can see on this tracking map, the blue line indicates the path that the Falcon 9 would follow if there are no maneuvers or burns of its engine, and the white line shows the trajectory that it will take with a nominal burn of that engine. Taking a quick look back at the launch pad where the Falcon 9 lifted off from 70 minutes ago. You see the strong back is back in the vertical position with some venting from the strong back. Normal part of post-launch reconfiguring of the pad, the safing of all of those systems. So we're about 90 seconds away from that burn of the second stage engine. We might hear a call for the chill down on that engine. With the Falcon 9 out over the ocean, the Falcon 9 could well be out of telemetry range. So we may not see video of that burn today, but we should hopefully hear some calls. About 30 seconds to the burn.
And back startup.
There we have confirmation from SpaceX. That second stage is now firing. You can see those blue lines are now expanding to It will eventually match that white line as the burn progresses. This burn will put the spacecraft into a highly elliptical orbit, which will allow it to reach the Lagrange point where these satellites are destined. The Lagrange point is the location in space where the gravitational force of the Earth and the Sun balance out, which creates a very stable parking. And there we have the call, the end of the burn. You can see that blue line has now completely disappeared from the tracking map. So that Lagrange 1 point creates a parking spot for spacecraft. This spot is located about 1 million miles from Earth. The deployment of IMAP will come first.
Nominal orbit insertion.
There's a call from SpaceX to confirm that the burn was successful. Placed the Falcon 9 second stage and its 3 payloads into the correct orbit. You can see that orbit in this track is soaring away from the Earth, heading for Lagrange point 1. The deployment of the first spacecraft, the IMAP mission, is coming up in about 7.5 minutes. So to recap, the Falcon 9 rocket lifted off from pad 39A at the Kennedy Space Center at 7:30 and 50 seconds this morning. The first stage separated from the second stage about 2.5 minutes into flight. The first stage descended towards a drone ship, while the second stage continued to place the 3 payloads aboard into a parking orbit. The first stage made a successful landing on the drone ship. Just read the instructions, which is stationed out in the Atlantic Ocean due east of Cape Canaveral. The second stage completed its first burn a little less than 8 minutes into flight. And we just saw the ignition of the second stage for a second time to boost the payloads out of their parking orbit, their circular parking orbit around the Earth, into a highly elliptical orbit, which will allow them to slip into the Lagrange point. And once again, that's the point where the Earth and the Sun's gravity balances out and creates a very stable parking spot for scientific missions. The James Webb Space Telescope is in one of these points, a different one, but same kind of principle. One advantage of being in that location instead of being in orbit around the Earth is you don't have to worry about passing behind the Earth and being in the shadow of the Earth and not being able to generate solar power. So in the Lagrange point, you can pretty much get a constant feed of sunlight. And that also, when you're wanting to study the sun, means you can study the sun 24 hours a day. We're 3.5 minutes away from the deployment of the IMAP spacecraft. You can see the orbital track of the Falcon 9 second stage is still out over the Pacific Ocean, but approaching North America. IMAP is the primary payload for today's mission, but also on board is the Space Weather Follow-on Lagrange 1 mission, or SWIFO L1, and the Carruthers Geocorona Observatory. Those deployments will follow the deployment of IMAP, which is now coming up in about 1.5 minutes. Deployment now 1 minute away. Hoping we will be within the range of ground stations and we'll get to see that deployment. We're about 10 seconds from deployment. And we see the spin-stabilized Falcon 9 second stage, waiting the deployment of IMAP.
IMAP deploy confirmed.
And there it is, deployment of the IMAP mission. This mission will be studying how the sun affects the environment around it, the so-called heliosphere. That spin up of the second stage creates stability for the deployment sequence. Something that was very usual to see during the early days of the space program, but not all spacecraft require that spin up. And as you saw, the spin of the second stage was slowed to a halt for the deployment of the 2 remaining payloads on this mission. We're looking inside the Johns Hopkins APL, Applied Physics Laboratory, mission control. They're hoping to acquire a signal from the spacecraft. And those controllers at Johns Hopkins still waiting to acquire a signal from the spacecraft. A little bit of sun glare on the camera now, but those are the 2 spacecraft remaining to be deployed. They're looking into that control center again. And they have received signal from the spacecraft. So that's good news for the IMAP team. The spacecraft is communicating with ground stations, using ground stations in Hawaii and Deep Space Network ground stations, most likely in California. So coming up in about 2.5 minutes will be the deployment of the SWIFO L1 mission, the Space Weather Follow-on Lagrange 1 mission. The SWIFO-L1 is designed to provide early warnings of space weather events such as coronal mass ejections from the sun. In addition to creating spectacular displays of aurora, those events, those violent events on the surface of the sun can disrupt communications and electrical systems, including satellites in orbit. And the SWIFO-L1 mission will help forecast potential danger from those events on the sun. Cameras alternating through the different views on the second stage, looking at that Merlin vacuum engine back at the spacecraft. Coming up on that deployment of the SWIFO-L1.
SWIFO-L1 deploy confirmed.
And there we have it, the deployment of the SWIFO-L1 spacecraft. It's the second mission that's dedicated to solar research on this rideshare flight. Coming up next is the Carruthers Observatory. The Carruthers Geocorona Observatory will, instead of looking at the sun, will be looking at Earth to capture the interaction of the solar wind with the Earth's outermost atmosphere. Here's a view of that spacecraft still attached to the payload adapter atop the second stage of the Falcon 9. The deployment of that observatory is scheduled to occur 1 hour, 36 minutes, and 46 seconds after launch. Nice view of the Earth as the Falcon 9 second stage climbs away, as you can clearly see in this trajectory map. This mission is named after Dr. George Carruthers, who was a researcher with the U.S. Naval Research Laboratory. And he proposed and designed a far ultraviolet camera spectrograph that flew on the Apollo 16 mission to the moon in 1972. He's also alumni of the University of Illinois, which is where this spacecraft was developed. There's that little slice of the Earth in that camera view. You can really see the altitude climbing as this mission heads to the L1 Lagrange 1 point. You can see there from the display in the bottom right of your screen that the Falcon 9 second stage is just past the 5,000 kilometer altitude mark. That's about 3,100 miles. Seeing a view inside the Carruthers control room. As you can see from the graphic on the screen, this control center is located at the University of California, Berkeley. The Carruthers Observatory was launch unpowered and will power up after deployment. So very critical milestone for that control team there in California. About 30 seconds away from deployment.
Carruthers, separation confirmed.
A little later than advertised, but there's the Carruthers Geocorona Observatory deploying from the payload adapter atop the Falcon 9 second stage. A spectacular view of the sun there, the focus of this particular mission. Taking a look back at the Carruthers Mission Operations Center.
Unofficially, it looks like they may have got AOS, but officially, we have not heard it yet on our nets. So we may have been seeing the reaction for the spacecraft separation and just general excitement about making it to this point, which is a big deal.
It's a very big deal, very big deal. Yeah, this mission was a mission where we had three payloads, and it almost was trying to be almost like it was 3 primaries. So I just want to give, once again, kudos to the team to getting this done. The team looked over almost 500 different requirement verifications they had to get this mission off. So just think about that. 500 different requirements you got to verify.
That's a lot.
So yeah, big deal.
Still waiting for that confirmation.
Yes, with L1 has telemetry at the mark.
Excellent news. Congratulations.
We just heard confirmation from NASA launch manager Denton Gibson was given confirmation that acquisition of signal has happened for SWIFO L1.
Yep, congratulations to SWIFO L1. Big accomplishment there.
It's two satellites now in communication with their ground controllers. Still waiting to hear on the Carruthers mission. Just dipping into the chat. I want to thank Super Tech Boy for a $2 super chat, a contribution towards Will's Rocket Insurance Fund. Also, a big thank you to Psychonaut69 for gifting a Spaceflight Now membership. If you were the lucky recipient of that membership, be sure to thank Psychonaut69. We are still getting some lost views from the Falcon 9 second stage. Beautiful shots of the Earth. Want to give a big thank you to the Spaceflight Now team for putting together today's broadcast. To Adam Bernstein, who was out early setting up the cameras for us this morning and tracked the rocket from the press site. To Pete Costins and Chuck and Jen Briggs for also providing support tracking this mission. Also thanks to Michael Kane, who was able to capture the transit of the Falcon 9 across the disk of the sun. To John Pisani for helping to run the technical side of today's broadcast. John and Adam have just returned from the launch pad, so we're looking forward to seeing some of their remote views. And of course, big thank you to Will Robinson Smith, who handled the pre-launch and launch portion of today's broadcast from Houston, where he's on assignment covering the Artemis II briefings and Monday's selection of the latest class of astronauts. So with that, I'd like to wish you a very good day, and we look forward to seeing you again tomorrow for more launch coverage. And we're expecting the flight of an Atlas V rocket and perhaps the odd Falcon 9 or 2. So for Spaceflight Now, I'm Stephen Young. Goodbye.